Okay, let's continue with the question 2. In the question 2, it's more or less the same question like what we have in the question 1. But in question 1, we discussed about the discrete time signal, but now we are taking the example of a continuous time signal. What we are interested? We are interested in multiplying the signal x of t with this particular signal. Okay, so let us first draw the signal u of t minus u of t minus 1. Now, this is a continuous time signal. We know that u of t means this is a unit step signal. So it means if it's a unit step signal, so u of t will be basically at 0. It will start from to the amplitude 1 and it will continue to the positive infinity by this one, by this amplitude 1 here. Okay, so this is your signal u of t here. Now, what is u of t minus 1? U of t minus 1 means I need to take this signal and I need to shift it to the right by 1 here. So u of t minus 1 means I will take my signal u of t, which I drawn earlier, and I need to shift it to the right by 1. So it means instead of 0, it will now start from 1 and it will go to the positive infinity with the amplitude 1 here. So this is your u of t minus 1. Okay, now what we are interested in plotting u of t minus u of t minus 1 here. So it's quite straightforward now. It's only just subtraction and addition stuff here. So you can see here, let me draw now between 0 and 1 here, the value here is 0, and between 0 and 1 the value here is basically 1 here, and we are subtracting this signal minus this signal here. So it means 1 minus 0 is going to give you 1 here. So it means between 0 and 1 I'm going to get 1 here. Okay, now between 1, after 1, let's suppose, okay, after 1 the amplitude here will be 1, and afterwards the amplitude here is again 1. So 1 minus 1 is going to give you 0. So it means all the values after 1 will come to 0 here. It will be continuing as 0 here. Okay, so this is nothing but this is your signal u of t minus u of t minus 1 here. Okay, now what we will do here, we will take the signal which we just plotted here and we will draw it here, and we can plot it like here, suppose here. Okay, and this is basically your signal u of t minus u of t minus 1 here. Now this quite straightforward, that I mean you can have a multiplication here. Let's suppose I use another color here. What we have, simple, between 0 and 1. So let's start from between minus 1, before minus 1 it's all 0, so it all 0, so 0 multiplied by 0 will give me 0. Between 1 and 0 I have a linear line here. Okay, now this signal means some value multiplied by 0 will always give me 0 here, so it means I'm going to get 0. I'm going to get 0 on this side here till here. Okay, next thing, now what we have after 1, the value here is 1, so 1 multiplied by 1 is 1 here, so it means after that I will get 1 here. Between 0 and 1 I will get 1 here. Now the third one is basically this portion here. Between 1 and 2 the value here is 2, so 2 multiplied by 0 will give me 0, so it means all the values here will be 0, and then after that all the values here are 0, so 0 multiplied by 0 will give me 0 here, so it means my signal value will be this thing only. Okay, and we can say like this, let's suppose this is your G2 Y2 of t, sorry I think so, Y2 of t here. Okay, clear with this? So this was your signal question 2. Okay, for the question 1. The question 1 is almost similar to what we did previously in question 1, basically the first part of this one. You can try that one yourself, okay? Let me give you quickly the third one, okay? Just 1 minute. Okay, the third part here is basically we need to multiply the signal x of t with some impulse signal which is t minus 3 by 2. So let us first plot what is delta of t and t minus 3 by 2 here, okay? So what we have basically here, so we have, for example, in case of continuous time signal, the impulse signal will be like something here, and you can put an arrow here, okay, just to differentiate from the different. So it means this is your delta of t here, okay? Normally it will be 1 here, but goes to infinity basically. Now what we have basically, it is delta of t. So delta of t minus 3 by 2 means I need to shift this impulse to the right by 1.5 or 3 by 2. Okay, so basically I'm going to get at 1.5 I will have an impulse. At 1.5 I will have an impulse. You can say like this is 1 here. Okay, so I will take this impulse and multiply it with the signal here. So it's quite straightforward. I'm going to get the signal value at 1.5. So you can see at 1.5 the signal value here is 2. At 1.5, like for example this is 1.5, the signal value here is 2. So it means I'm going to get my answer will be basically like I am going to have at 1.5 impulse, and the value of the impulse will be 2 here. Okay, so this is your signal y3 of t here. Okay, we can also use the same approach what we used previously, and by using the properties here. The properties was like, for example, it will be like it will be x of t multiplied by some impulse t minus alpha, where alpha is a constant here. So I will get basically x of alpha into delta of t minus alpha. In this case, the value of alpha is 3 by 2, which is 1.5. So I will get basically, sorry, I will get x of 1.5 into delta of t minus 1.5. Okay, and if you plot the signal, it will be same here. Like delta of t minus 1.5 will be an impulse like this. Will be an impulse like this, and the value of the signal at t equal to 1.5. So if t equal to 1.5, the signal value here is 2. So it means I will get the impulse value as 2 here. Okay, thank you.